Well, hi everyone. Let's go over this. The first 5 terms of this arithmetic sequence. A1 is 3, D is 4. First term, 3, D is 4, so let's go up by 4. 7, 11, 15, and 19. That's all there is to that. Now this one, let's figure out what D is. So I'm going to take the 10th term minus the 4th term and divide it by 10 minus 4. That's how many times I'm adding D. And then we're talking about 18 over 6, which is 3. So D is 3. My 4th term is 10. If D is 3, then I'll subtract. I got 7, and I got 4, and then I got 1, and then one more term over here, 13. Now, find a formula for A sub n for the arithmetic sequence. So A sub n is equal to A sub 1 plus n minus 1 times D. And I will have that on a formula sheet. I have all the formulas that I write out here will be on a formula sheet for you. So A sub n is the first term, which is 100 plus n minus 1 times negative 3. Okay, and I would be okay if you stop there. I'm going to keep going, and I'll make this negative 3n plus 3. And A sub n would equal negative 3n plus 103. Now, they also said find the sum of the first 25 terms. Now, S sub n is equal to n over 2 times A sub 1 plus A sub n. That's the one Gauss used when he was a boy. And so S sub 25 is 25 over 2 times the first term, which is 100. Let me come down here and find A25. And that is negative 3 times 25 plus 103, which is 28. So I have 28 there. And the sum of the first 25 terms, so I've got this for one of my answers. Sum of the first 25 terms, I'm going to take 12.5 times 128, and that is 1,600. Thank you, Claire. Now, A1 is 10, A3 is 28. I'm going to figure out what D is. 28 minus 10 over 3 minus 1. That's 18 over 2, which is 9. Okay, so D is 9. A sub n is equal to A sub 1, which is 10, plus n minus 1 times 9, D, which is 9. D is 9 this time. And that's 10 plus 9n minus 9. So A sub n equals 9n plus 1. All right. And then the first 25 terms. So S sub 25 is equal to 25 over 2 times, let's see, A sub 1, which is 10, plus, and I forgot to find S25 again, no, A25, the 25th term. That's 9 times 25 plus 1, that's 225, that's 226. And let's take that 12.5 and multiply that by 236. That's what those add up to. and I'm looking at 2,950. Circle that one too. All right. This is a geometric sequence. First 5 terms. 100 is the first. I'm going to take 100 times 1.05 because that's R. 105 is the second term. I'm going to times that by 1.05. 110.25 is the third term. Times that by 1.05. 115.7625 is the fourth term. And times that by 1.05, and I'm looking at 121.550625. All right. Number 6. Let's do a little bit of calculating here. Now, we are multiplying by something R. 5 times R gives me A3. 5 times R gives me A4. Well, if we calculate that, I'm going to multiply, to get from the second to the seventh, I'm going to multiply by R 5 times. 5 times R times R times R times R times R, and I get this 0.0016. Then I'll divide by 5. Divide that by 5. Okay, and that's 0.00032. And I'm going to take the fifth root of that. R to the fifth is 0.00032. 1, 2, 3, 4. Yeah, 3.2 times 10 to the negative fourth power. And if I take the fifth root of that, well, let me put a 5 in. Well, actually, I'm going to put a 5. Then we're going to go to math, and I'm going to go to this one, and that puts it up there. Some of the older calculators won't show that, but it's going to do it for you. And you can put in answer. You could go like this. Second, I hit the second, and then the negative button, but its other function is an answer. I can put the answer, the last answer that I had in there, and I get 0.2. So R is 0.2. So that's going to help. Oops. So 5 is the second term. 5 times 0.2 is the third term. 1 times 0.2 is the fourth term. And 0.2 times 0.2, which would be 0.04, is the fifth term. I don't have the first term, so I'm going to take 5. I'm going to divide by 0.2, and that is 25. Now let me take 25 times 0.2 real quick, and I get 5. Okay, so there is my first 5 terms on that one. Now, A sub n is equal to A sub 1 times R to the n minus 1 power. That's how we get the formula. One of the formulas we have for sum of a geometric sequence is S sub n equals A sub 1 times 1 minus R to the nth power over 1 minus R. All right, so I am going to go for the formula. A sub n is equal to A sub 1, which is 100, times negative 0.5 to the n minus 1 power. So that's good. And I'm going to take S sub 25. I want to find the first sum of the first 25 terms of this sequence. And it is 100 times 1 minus negative 0.5 to the let's see, 25th power over 1 minus negative 0.5. Okay. I was just checking. Just this is raised to the 25th power. And 1 minus, this is 1.5, so I'll divide by 1.5 at the end. I'm going to try to calculate that numerator right now. And I'm going to take 100 paren 1 minus, and then I'm going to put negative 0.5 in parentheses there, and raise that to the 25th power. Bring down my cursor and close that. Alright, that should give me the numerator, and I'll divide by 1.5 and see what happens here. Okay. I am going to take I'm going to say this is, might be approximate, may be exact, I don't know. 66 2/3. I see all these sixes, but then I don't see sixes after that. So I'll put approximately that. Okay. Here, R is 3. Now I saw some people do this problem, and it's a really big problem. I mean, the answer is really big when you get the sum. Now, as far as writing the formula, the first term is 2. You go times 3 to the n minus 1. Now, the sum of the first 25 terms, we're going to take 2 times 1 minus 3 to the 25th power, which is a really big number, over 1 minus 3. So I'm going to divide by negative 2 on that one. So we got 2, whoa, how did I get out there? Must have had the shift key on. Alright. 2 paren 1 minus 3 to the 25th. Bring that cursor down. The C's. Divided by negative 2. Okay, I'm going to go approximately 8.47 times 10 to the 11th power. That's what I got there. Okay. All right, partial sums. This is arithmetic. This is not arithmetic. This is geometric. And I might show you both ways. Geometric is when you have this to a power. This is when you got like a linear expression. This is when you have an exponential expression. You're going to have a geometric. So remember, S sub n is equal to n over 2 times a sub 1 plus a sub n, and that we're talking 10 terms. So n is 10. 10 over 2, the first term, put 1 in for that. 2 times 1 minus 3 is negative 1. The 10th term, 2 times 10, because we stop at 10, 20 minus 3 is 17, and that's 5 times 16, which is 80. And we can check out on the calculator using the summation function here. Summation, I'm going to put x here, 1 oops, put 1 here. Let's get back up here, put 10, and 2x minus 3. 2x minus 3. 80. I almost think I did this just almost as quick as plugging that in. All right. This is 101 terms. That's 101 terms. Now, if I were to use, R is 2/3, by the way. If I were to use this, a sub 1 is when you have a 0 here. So we're taking 10 times 2/3 to the 0 minus 1, negative first power. Now that's 10, this is going to be 15, because 2/3 to the negative first power is 3/2 to the first power. And 10 times 3/2 is going to give you a 15. I'm just giving you a predictor here before I do it. So it's the first term, which is 15, times 1 minus 2/3 to the 101st power over 1 minus 2/3. Okay. Now, I'm going to do a little bit of algebra here. 15 times 1 minus 2/3 to the 101st power over 1 minus 2/3. That's 1/3. And if I multiply top and bottom by 3, then I have just 1 in my denominator. So we're looking at 45 times 1 minus 2/3 to the 101st power. Let's try that. 45 times 1 minus 2/3 to the 101st I get 45. Oh my. Okay, so I got 45 with that. Now let's try the summation. That's saying that this is so small, 2/3 to the 101st power, that it's almost negligible. Taking 1 minus 0, basically. 2/3 to the 101st power is very, very small. And it's the rounding capability of the calculator. I'm curious to see what happens when we do the summation. Summation. Did I hit second? No. No. I hit math. Summation. X equals 0 to 100. Let's go 10. Let's put 2/3 here. Close that. To the power of x minus 1. We're asking a lot of this thing here, this calculator. I think that's put in correctly. Yeah, 10 times. Okay. See, it's processing all that. Woo. All right. Now, binomial theorem. Okay. I'm going to write Pascal's triangle. 1. You need to know how to write Pascal's triangle. That is not going to be on your formula sheet. 1, 1, 6, 15, 20, 15, 6, 1. I see a 7th power here, so 1, 7, 21, 35, 35, 21, 7, and 1. All right. Now, x minus 3, I'm going to do this in parts here. X minus 3 to the 5th power, then I'll distribute the 2. But you got to do the exponent first. So, I'm going to use this row. 1, 5, 10, 10, 5, 1. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0, and then negative 3 to the 0, negative 3 to the 1st, negative 3 to the 2nd, negative 3 to the 1st, negative 3 to the 0, and negative, 0, 1, 2, 3, 4, I don't know why I started going down again, 5. Okay, let's put our pluses in here. All right, this is x to the 5th. 5 times negative 3 minus 15x to the 4th. 10 times 9 plus 90 x cubed. 10 times negative 27 minus 270 x squared. 5 times 81 plus 405 x. There's 90. No, okay. Now that's x to the 1st. That's right, x. Negative 3 to the 5th power. That's negative 243. Okay, I'm going to go ahead and distribute that 2. And we're talking 2x to the 5th minus 15x, nope, 30x to the 4th plus 180x to the 3rd minus 540x squared plus 810x minus 486. All right, that's what this one's equal. And what am I going to subtract from it? Well, I got to do this. 3x minus 2 to the 4th power. I'm going to use the 1, 4, 6, 4, 1 line. I got 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, and 3x to the 0. Then I got negative 2 to the 0, negative 2 to the 1st, negative 2 to the 2nd, negative 2 to the 3rd, and negative 2 to the 4th. All right, now it's time to, 3 to the 4th is 81, 81x to the 4th, 3 to the 3rd is 27, 27 times 4 is 108, 108 times negative 2 is negative 216, and that's x to the 3rd. Let me try that again. That's not right. Wait, this is 27. Okay, I'm okay. That's, okay. 9, 54, 54 times 4, and that's positive 216, x squared. All right, that's negative 8, negative 32, that's negative 96x. That's 1, 1, and 2 to the 4th is, that's positive 16. All right, I am going to subtract this from this and write the answer somewhere. I'm going to write the answer up here. 2x to the fifth, it's the only x to the fifth. Negative 30x to the fourth minus 81, I think is negative 111x to the fourth. Oops. 180 plus 216 is 396 x cubed. Negative 540 minus 216, that is negative 756 x squared. 810 plus 96 minus the negative, 810 plus 96, that is 906 x. Negative 486 minus 16 is negative 502. I think that's the answer. All right, 3x plus y to the seventh. Let's put the 1, 7, 21, 35, 35, 21, 7, and 1. 3x to the seventh. 3x to the sixth, 3x to the fifth, 3x to the fourth, 3x to the third, 3x squared, 3x to the first, and 3x to the 0. Y to the 0, y to the first, y to the second, y to the third, y to the fourth, y to the fifth, y to the sixth, and y to the seventh. Pluses in between all these. Okay. 3 to the seventh power. I'm not sure I know that. 43, 7, 29. I'm going to cheat. 3 to the seventh. 2,187 x to the seventh. Let's take 7 times 3 to the sixth. I get 5,103. X to the sixth, y to the first, plus 21 times 3 to the fifth. That's another. Isn't that interesting? How we're getting the same numbers in a lot of these. 5,103 x to the fifth, y to the second. Let's go 35. 3 to the fourth is 81, so I'm going to go just times 81. And that's 2,835 x to the fourth, y to the third. I'm on that one now. 35 times 27, 945 x cubed, y to the fourth. 21 times 9 is 108 x squared, y to the fifth. There's a fourth power there. (21) x, y to the sixth. That's 1 plus y to the seventh power. All right. Number 13, 14, and 15 are these, involve these matrices. I forgot to draw the brackets on them. Dimensions of A. Rows, columns. 2 by 3. 3B. So 3 times negative 4, negative 9, negative 4, 4, 4, negative 7, negative 9, minus matrix D, which is negative 4, negative 5, 8, 8, negative 9, negative 7. All right, let's do this. Let's distribute. I'm going to go negative 12, negative 27, negative 12, 12, negative 21, negative 27. I'm going to change this to addition. I'm going to go plus, and then on the opposites of all these. 4, 5, negative 8, 9, and 7. And then, just cell by cell, match them up. Negative 12 plus 4 is negative 8. Negative 27 plus 5 is negative 22. Negative 12 plus negative 8 is negative 20. 12 plus negative 8 is 4. Negative 21 plus 9 is negative 12. Negative 27 plus 7 is negative 20. Oh dear. Okay. Make those brackets right. All right. The matrix that represents BE. Where's B? There's B. So I got to write it first. The order matters. Negative 4, negative 9, negative 4, 4, negative 7, negative 9. And E is 4, 9, 3, negative 4. Okay, row, column. First row, first column, I take negative 4 times 4 plus negative 9 times 3. First row, second column, I take negative 4 times 9 plus negative 9 times negative 4. Second row, first column, negative 4 times 4 plus 4 times 3. And then negative 4 times 9 plus 4 times negative 4. And then third row, first column, negative 7 times 4 plus negative 9 times 3. Then you got negative 7 times 9 plus negative 9 times negative 4. Okay, there it is. Let's just do the calculations. So 3 by 2 matrix. Negative 16 plus negative 27 is negative 43. Negative 36 plus positive 36 is 0. Negative 16 plus 12 is negative 4. Negative 36 plus negative 16 is negative 52. Negative 28 and negative 27 is negative 55. Negative 63 plus 36 negative 63 plus 36 is negative 27, I believe. Okay. Yeah. 27 and 36. Yeah. All right. Now, let's take a look at number 16. Explain the elementary row operation performed, and I didn't get the brackets in again, to obtain the new row equivalent matrix. All right, first row was left alone. Now we got this. Third row was left alone. Let's see. I think negative 3 times 1. I think we are looking at negative 3 times row 1 plus row 2 to get this new row 2. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 0 is 0 plus 1 is 1. Negative 3 times 2 is negative 6 plus 7 is 1. Yep, that's the ticket. Now we're going to have to use that kind of stuff and decide what we want to do here. And 17, this is the one. I'm already 35 minutes into this video, and I'm just now starting this one. All right. And this may get downloaded a little later in the evening than I anticipated. 3, 4, negative 1, 17, 5, negative 1, 2, negative 2, 2, negative 3, 7, negative 21. Okay. There's different things we can do. I am going to deal with halves for a little bit. And I may not have to deal with them for too terribly long. But I'm going to take 1/2 times row 3 at 3, 4, negative 1, 17, 5, negative 1, 2, negative 2, 1, negative, I'm going to go decimals, negative 1.5, 3.5, negative 10.5. All right, I don't know if I'm going to be sorry or not. You just really never know on these sometimes. I'm going to swap row 1 and row 3 so I have the 1 at the top. 1, negative 1.5, 3.5, negative 10.5, and then 5, negative 1, 2, negative 2, 3, 4, negative 1, 17. All right. I'm going to take negative 3 times row 1. Oh, wait. Let's do it in order. Negative 5 times row 1 and add it to row 2 to get a new row 2. Row 1 stays 1, negative 1.5, 3.5, and negative 10.5. And I'm just going to do one thing at a time on this. I was tempted I was going to go negative 3 times row 1 plus row 3 and just do that as well, but I'm just going to do one thing at a time. Let's just see how it shapes up. All right, negative 5 plus 5 is 0. Negative 5 times negative 1.5 is 7.5. Minus 1 is 6.5. Negative 5 times 3.5, that's negative 17.5, plus 2 is negative 15.5. And negative 5 times 10.5, you know what, I'm going to check these real quick because I don't want to goof this up. So negative 5 times negative, you got to turn your calculator on. Okay, negative 5 times negative 1.5 plus negative 1, okay, that is 6.5. Negative 5 times 3.5 plus 2, that is negative 15.5, negative 5 times 10.5 plus negative 2 is negative 54.5. And what do we have here? We have, okay, I'm going to just put the 3, 4, negative 1, and 17 in. And now I'm going to go negative 3 times row 1 plus row 2. Row 1 stays the same. If they're just 0.5s, this won't be too bad. Famous last words, right? Negative 54.5. Okay, let's do this calculation. That's 0. Negative 3 times negative 1.5 plus 4, 8.5. Negative 3 times 3.5 plus negative 1 is negative 11.5. Yikes. Okay. Negative 3 times negative 10.5 plus 17 is 48.5. Okay. All right, 17, 23. Okay. 13, 31. All right, at this point, I'm going to just kind of take a new direction here and maybe deal with one of these negative ones first. All right, I'm seeing this and I'm seeing it get messy. I could continue or I can try a new path, and I'm going to try to go for that 0, 1, 0 first. So I'm going to take negative R2, negative 1 times R2, if you prefer. And I'm going to go a new path here. So I got 3, 4, negative 1, and 17, negative 5, 1. See, I got my 1 here, negative 2, and 2. I change all the signs properly. Okay. And 2, negative 3, 7, negative 21. Okay. And then I'm going to do 2 at a time rather than doing 1 at a time like I was doing there. I'm going to try to get a 0 here and a 0 here. So I'm going to take negative, wait, let me do it up here. Negative 4 row 2 plus row 1. And that'll give me my new row 1. And then I'm also going to take 3 row 2 plus row 3 to get my new row 3. Row 2 stays the same. Negative 5, 1, negative 2, and 2. Okay. Negative 4 times negative 5 is 20, plus 3 is 23. And then I got my 0. Negative 4 times 1 plus 4. Negative 4 times negative 2 is 8. Negative 1, that is 7. Negative 4 times 2 is negative 8 plus 17 is 9. I think that's right. Negative, or 3 times negative 5, that's negative 15 plus 2 is 17. Negative 17. This is 0. Negative 6 plus 7 is 1. Ooh, I like that 1 there. I think we're going to go with this column next. This looks a little messy there. And then negative 63. Oops. No. 6 plus negative 21 is negative 15. Be very, very careful. All right. I am going to deal with this one. And I got this 1 here, which is right where we want it. Let's make zeros here. So let's take negative 7 row 3 and add row 1. Then let's take 2 row 3 and add row 2. And we'll get our zeros. You see the 7, 1, I'm only looking right here. I'm looking at these two numbers. Negative 7 times 1 plus 7. 2 times 1 plus negative 2. That's all I'm looking at to make these determinations here. Let's do that. My new row 1. Negative 7 times negative 17. Negative 7 times negative 17 plus 23. 142. All right. Negative 7 times 0 plus 0 is 0. Negative 7 times 1